Okay, this is our video for section 8.4. They call it radical equations. I just call this algebra's favorite game, of course, which is find x. Again, radical equations, that means we're dealing with this square root symbol or root symbol. Sometimes it could be a third root or a fourth root or a fifth root and so on and so forth. But most of the time, we're just going to see it as a square root. And this is how it works. Let's just take a look at some examples because I think that's the easiest way to do this. The first thing you want to do is you want to make sure that whatever is underneath the radical and with the radical, you want this all on one side of the equation. So notice how the radical is on the left and then the rest of the equation is on the right. For this equation, all we're talking about is 4 being over here on the right. So the next thing we want to do is we want to get to our x. So we're going to get rid of this radical symbol. To do that, we are going to square both sides. On the left here, that's going to get rid of my radical. So I'll be left with 3x minus 5 equals, and when I square my 4 here, I'm going to get 16. Now, just classic solve for x. This is Algebra 1 stuff from here. So we're going to add 5 to both sides, which will give us 3x equals 21. And then we divide by 3 on both sides, which gives us that x equals 7. We're not done, though. On all of these problems, we need to check to verify that 7 is actually a solution. Sometimes with these irrational functions, weird things can happen with inside the radical. And sometimes that'll screw up the whole problem completely. So we got to go back and check to make sure 7 actually is a solution. So let's plug this in. We get 3 times 7 minus 5 equals 4. This is 21 minus 5 equals 4. This is the square root of 16 equals 4. And we're going to get 4 equals 4. Remember, for this whole section, all we care about is the positive coming out of square root symbols. So it turns out that 7 actually is a solution, so we can come back and we can square this. Okay, let's do another example. Okay, our next example here is radical x squared minus 9 equals 4. The first thing you want to do is make sure that all of the radical stuff is on one side of the equation, and all of the stuff that has no radicals attached to it is on the other side. So I'm set up that way. I have my radical x squared minus 9 on the left and my normal stuff on the right. To get rid of the square root sign, I'm going to square both sides. This will give me x squared minus 9 equals 16. From here, I just want to solve for x. So I'm going to add 9 to both sides. This will give me x squared equals 25. From here, I can take the square root of both sides and get that x equals 5. Now, again, I know it's positive or negative 5, but all I care about is the positive. So the only thing I'm going to check is x equals 5. So let's check this. The radical of 5 squared minus 9 equals 4. 5 squared is 25. Minus 9. Does this equal 4? Oh, I guess I should be putting question marks right here because I just don't know yet. So this is root 16 equals 4. Well, yeah, I can confidently say that 4 does equal 4. So my check has worked, and I can now come back and say that x does indeed equal 5. Let's do one more. Okay, for this problem, we have radical x plus 4 plus radical x minus 4 equals 4. When we're presented with the case where we have 2 radicals, what we want to do is we want to isolate one of them. So what I'm going to do is I'm going to subtract the square root of x minus 4 on both sides. And I'm going to isolate my x plus 4 over here. So I'm going to be the new equation of x plus 4 equals 4 minus the square root of x minus 4. Okay, now I'm going to do the same as I've been doing in my other equations. I'm going to square both sides. So I'm going to square here. On this other side, again, I have to square the entire thing. What's this going to do for us? Well, it's going to get rid of this radical sign over here. So I'll have x plus 4 equals. And then over here, we got to do binomial distribution. So let's come over here and do that. Slide over. So we have 4 minus the square root of x minus 4 times 4 minus the square root of x minus 4. Okay, so this is just binomial distribution. So again, you guys like to use that FOIL idea. I don't like that because again, it only works for binomials. So this is binomial distribution. 4 times 4 is 16. 4 times negative radical x minus 4 is minus 4 times x minus 4. Then we get negative x minus 4 radical times 4. So we get another minus 4 times x minus 4. And then lastly, we get radical x minus 4 times radical x minus 4. It's going to end up being plus x minus 4. From here, we can start to clean this up a little bit. This is going to be, let's see, 16 minus 4 is 12. X has nothing to add to or subtract to, so that's just going to hang out by itself. And then we have 8 of the radical x minus 4s. So we'll say minus 8 radical x minus 4. Okay, and we're all done there on the distribution. Now let's bring it back over to the problem and see what did it do for us. Okay, well, we've gotten rid of one of our radicals, but we're still left with one here. So let's keep cleaning things up. Let's see, if I subtract x on both sides, my x's are going to cancel out. Let's see, I can subtract 12 from this side also, which will give me that I have negative 8 equals negative 8 times the radical of x minus 4. From here, I want to get x minus 4 by itself. We're going to go back to exactly what we were doing on the last two examples. So we want to get this radical by itself. So again, I'm going to divide by negative 8 now. This will give me that 1 equals the square root of x minus 4. And check it out. Now we've isolated the radical once again. So we're just going to do exactly what we did before. All that required here, since we had two radicals, we've had to do 2 steps. We cleared this radical, gone through the mathematics, cleaned up, isolated another radical. Now we're just going to square both sides. This 1 squared is 1. Radical x minus 4 squared equals x minus 4. Let's solve for x. We'll get that 5 equals x. Once again, we have to check to make sure that this is true. So I'm going to check. I'm going to plug into my original equation. So I'm going to have the square root of 5 plus 4 plus the square root of 5 minus 4. And supposedly this should all equal 4. Let's see. 5 plus 4 is 9. 5 minus 4 is 1. Equals 4. The square root of 9 is 3. The square root of 1 is 1. And does this all equal 4? Oh, I guess these should all be question marks. And again, I can indeed confirm that 4 does equal 4. I've checked off, and I can come back and square that x does equal 5. This is going to be the idea for finding x. We need to clear the radicals on either side. If you have any questions or comments, please let me know. Other than that, we'll see you all tomorrow.